Hello everyone. In this lecture we will be discussing about the hydroxyl radical in the atmosphere. OH radicals derive most of the reactions in the atmosphere as it is the most important oxidizing species in the atmosphere. It is extremely reactive and able to oxidize most of the chemicals found in the atmosphere. The hydroxyl radical, OH radical, is also called as detergent of the atmosphere or atmospheric scavenger. So why the OH radical is important? Because it derives most of the reactions in the atmosphere and it is also called as detergent of the atmosphere or atmospheric scavenger. Why? Because it has a significant role. OH radicals has a significant role in self-cleansing capacity of the atmosphere. So OH radicals has a significant role in self-cleansing capacity of the atmosphere. Therefore, they are called as detergent of the atmosphere or atmospheric scavenger. So how do they cleanse the atmosphere? They cleanse the air by oxidizing methane, carbon dioxide and VOCs. It will also break down the organic pollutants in the atmosphere and making them less harmful compounds. So that's why the OH radicals in the atmosphere are very important and also called as atmospheric detergents or atmospheric scavenger. These OH radicals govern atmospheric chemistry during the daytime since its formation depends on radiation from the sun. So basically the formation of OH radical depends on the solar radiation and it governs the atmospheric chemistry during the daytime. In its formation process, the initial reaction involves the breakdown of ozone by solar radiation of 320 nanometer and gives the oxygen molecule with an oxygen atom. This oxygen atom so formed will react with the water and give us the most important oxidizing agent of the air, that is OH radical. Therefore, we can conclude from these reactions that the formation of OH radicals in the atmosphere depends on two important factors. One is the presence of solar radiations and the other is the water vapor present in atmosphere. So these are the two key factors such as solar radiation and water vapor present in the atmosphere prerequisite for the formation of OH radicals in the atmosphere. So the formation of OH radical in the atmosphere depends on the solar radiation and water vapor present in the atmosphere. So it has been found that more than 97% of the oxygen atoms which are formed by photolysis of ozone, reacts back again to form ozone. Only 3% starts the formation of most important radical in the atmosphere, that is OH radical. For example, अगर हमारे पास 100 ऑक्सीजन आटम्स बनते हैं ड्यूरिंग दिस रिएक्शन प्रोसेस, 100 ऑक्सीजन आटम्स बनते हैं, आउट ऑफ दीज 100 ऑक्सीजन आटम्स 97 will react back to form ozone. Then only 3% of these oxygen atoms formed will react with water to give us OH radicals, The OH radicals are extremely reactive radicals. It reacts as soon as it is formed. Therefore, the lifetime is less than a second. So जैसे ही हमारे पास ये OH radicals form होंगे, they will react as soon as possible within a second. So their lifetime is about less than a second. So OH radicals have a lifetime of less than a second. Since its formation, OH formation depends on solar radiations and water vapors, its distribution is also important at the global scale. So, its formation depends on water vapor. The concentration of OH radical tends to decrease with altitude as the air becomes cooler and drier. What does this mean? This means that if we are on the surface of the earth, this is the surface of the earth, as we move upward in the atmosphere, that means with the increase in the altitude in the atmosphere, the concentration of OH radicals will decrease. With the increase in altitude in the atmosphere, as we move upward in the atmosphere, the OH radicals will decrease. Why? Because as we move up in the atmosphere, the air becomes drier, right? The availability of atmospheric water vapors are less as we move upward in the atmosphere, therefore leading to the less concentration of OH radicals in the higher altitudes. So this was the one point about the distribution of, or the vertical distribution of OH radical in the atmosphere. And the other point is hydroxyl radical concentrations also decrease with latitude, because both the water vapors concentration and intensity of the sunlight decrease as you move towards the pole. So this is the second point. So what does this mean? As we move towards the pole, the concentration of OH radical decreases. So what does this mean? This means that if this is our earth, and we are at the equator. This is equator, and this is our pole. It says that when we move away from the equator towards the pole, the concentration of OH radical will decrease. The concentration of OH radicals will decrease as we move away from equator. As we move away from equator, the concentration of OH radical will decrease. Why? Because both because both the concentration of water vapors and intensity of solar radiation decreases as we move away from the equator towards the pole. So, due to the less intensity of the solar radiation and drier conditions such as less amount of water vapor present in the atmospheres of the pole, the concentration of OH radical will be less. So the second point means that as we move away from the equator towards the pole, the concentration of OH radical will decrease due to the lower intensity of solar radiation at pole and less amount of water vapors in the poles. So this is about the spatial distribution of OH radicals at the global scale. However, if we talk about the diurnal variation of OH radicals in atmosphere. What is meant by diurnal? That means day and night variation. मतलब कि पूरे दिन में किस टाइम पे OH रेडिकल्स की कंसंट्रेशन ज़्यादा होगी और किस टाइम पे कम होगी. So this is the diurnal variation of OH radical in the atmosphere. What is the trend of diurnal variation of OH radical in the atmosphere? It will be in this form. Say for example, at this axis we have OH radical concentration. At this we have the time. This is, say for example, 12 a.m. at night. This is 6 a.m. in the morning. This is again 12 noon, and this is around evening 6 p.m. and then again it is night. So the concentration and the trend of OH radicals during the day times would be in this way. It would be in this way. So the concentration of OH radical would be high at around noon and afternoon time. Why the concentration of OH radical will be high around noon and afternoon time? Because the solar radiations are high during these times. So this would be the trend of OH radicals in the atmosphere for 24 hours. Now, how much OH is formed and is consumed? How much OH radical is consumed by different pollutants? यानी कि if we have different types of pollutants in the atmosphere, such as carbon monoxide, carbon dioxide, we have methane, we have organic compounds, and others such as ozone, water, and hydrogen. So what is the consumption and proportion of these pollutants? So OH radical, about 40 on a global scale, about 40% of the OH radicals react primarily with CO and forms the CO2. So we can say that CO consumes about 40% of the OH radicals. CO consume about 40% of the OH radicals. On the other hand, 30% of the OH radicals will be consumed by organics organic compounds, and 15% of the OH radicals will be consumed with methane, and 15% remaining will be consumed by ozone, peroxy radical, and hydrogen. So together, carbon monoxide and methane consume about 40 and 15, that is 55% of the OH radicals. So 55% of the OH radicals are consumed by carbon monoxide and methane. So this was the consumption of OH radicals by different pollutants in the atmosphere.